All right, so this is Chapter 7, Section 3, Proving Triangles Similar. So right here I have a picture of similar triangles. Our learning objective is to use the angle-angle postulate and the side-angle-side and side-side-side theorems, and to use similarity to find indirect measurements. So if I'm finding measurements indirectly, I am not taking out my ruler or my protractor and calculating them. All right, so let's put down this one here. I didn't grab the title with this. This is the angle-angle postulate. Okay, so this is how it rolls down. If I have two angles, so here it's S is congruent to M, and R is congruent to L, and yes, you should have a picture because you're never going to encounter these just in words. They're always going to come with a picture. So if I have two angles in two different triangles that are congruent, so I need two pairs, then my triangles are similar. And just for the record, one little squiggly mark, it's called a tilde. When you're taking Spanish, it makes an N and N. That tilde sign means similar. So a nice little squiggly tilde, which is different than the congruent sign we've been using. So that's the angle-angle. All right, so the side-side-side similarity theorem says if all my sides, so AB and QR, AC and QS, and BC and RS, if those proportions are all equal, then my triangles are similar. So this is a little different than side-side-side congruence. This is just saying if my proportions, if all the proportions are equal, then my two triangles are similar. All right. Side-angle-side similarity says if two sides, this guy and this guy, and this guy and this guy, and the angle in between them. So if I take if the proportions between those two sides are equal, and the angle in between those two sides are congruent, then the triangles are similar. All right, so here we're going to talk about indirect measurement. So we are going to use indirect measurement to find lengths that are difficult to measure directly. For example, I am not going to take a measuring tape and shimmy up the flagpole to measure the distance from the ground to the top of the flagpole. But I can measure it indirectly, and we'll do that next week. So there's going to be some distances that you can't directly measure. So we use, it's kind of like a math ninja to indirectly measure it. We use proportions, in fact, like the shadow that the flagpole casts. You can use that to indirectly measure the distance of the pole.
But it was just like a...
All right, so if we look at this problem, are the triangles similar? If yes, write a similarity statement and explain how you know they are similar. So I have two triangles here. This guy is 100, this is 35, this one's 45, and I have to somehow figure out if they're similar. Am I given any information about the side lengths of the triangle? Any little congruent marks on the sides to show any distances. I'm not given any information on the sides, so I don't want to use side, 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 or side, angle, side to prove that anything about these triangles because I have no information on the sides. So I'm going to focus here on the angle, angle postulate. So all I need is that two pairs of angles are congruent to show that these triangles are similar. That. Angles. So thanks to vertical angles, I have one pair, angle AEZ is congruent to angle REB. So I have one pair of congruent angles. How am I going to find a second pair? What do you got, Zach?
You can add them all together and then minus 180 by the sum of the two numbers.
Right. Yeah, let's find angle. I can either find angle Z or angle R. Or just for fun, we can find both. So triangle sum theorem says that all the angles inside of a triangle equal 180. So if I go 180 minus 100 minus 35, 180 minus 100 is 80. 80 minus 35 is 45. So then I can say angle Z is congruent to angle B. And all I need is two pairs of congruent angles. So if yes, so are the triangles similar? Yes. They are similar. Always go back and read the question to make sure that your answer, because we do all this math chugging around, and if we are not looking at the question, sometimes we solve for x, but they don't want x, they want the sideline. So if yes, they are similar. Write a similarity statement. So let's go triangle ZAE is congruent. Okay, so who's Z's buddy over here?
R. No, I'm sorry, B.
B. Okay, who's A's buddy?
R.
R. And then B. We have only B left. E is its own buddy. Oh, cute. Okay, yes, they are similar. Triangle ZAE is similar to triangle BRE. And explain how you know they are similar. By the angle postulate. I think there's an angle similarity postulate.